Hi students, this is Karthik Trivedi and you are watching a lecture series of engineering graphics and design with me. So in last video we have seen the example of inferior trochoid and superior trochoid. So in today's video we're gonna see an example of epicycloid. So let us see the example on your screen. So example is, draw a locus of a point on a periphery of a circle which rolls on a curved path. Take a diameter of rolling circle 50 mm and radius of directing circle 75 mm. Okay, so now here first we will understand what is epicycloid. So whenever one circle rolls on another big circle, so there are basically two circles, one smaller circle and there is another big circle. So what is happening over here, that the smaller circle is rolling on another big circle outside. So that condition is known as epicycloid. Okay, so here you can see that the smaller circle that we have is a rolling circle and the bigger circle that we have, that is we gonna call it a directing circle. Okay, so now first we will write a given data. So here in given data we have a diameter of rolling circle which is equal to 50 mm. So radius will be what? It will be a 25 mm. So we call it a radius small r. Small r means rolling circle radius. Okay, and now there is another big circle which we call a directing circle. So radius of directing circle is given which is 75 mm. So we call it capital R. Okay, so that capital R will show the radius of directing circle. So here we have a two circle over here, a smaller circle that we will call rolling circle and the radius will be smaller, and there is another big circle which we call a directing circle and it is having a radius capital R. Okay, so whenever I say a small r, that means I'm talking about rolling circle. When I say capital R, that means I'm talking about the bigger circle which is directing circle. So the radius of directing circle which is bigger circle is given the radius which is 75 mm. So what we will do, first we will draw a radius of bigger circle, that means a directing circle. So first we will draw a radius of directing circle like this. But before we do that, we have to find one angle theta. Why I'm finding angle theta over here? Because you know, when you draw you have to draw a curved path. You have to draw a one curved path having angle theta. So now that's why you have to calculate this equation, or you have to calculate this formula, so that we will derive the value of angle theta for the curved path. Why we are doing this, that we are going to understand later on. So here the equation of theta is small r upon capital R multiplied by 360 degree. So here a small r is 25, capital R is 75. So 25 divided 75, that is 1/3 multiplied by 360 degree. So the value of theta will be what? Yes, 120 degree. Okay, so now we have a value of theta equal to 120 degree. Now first we will draw a radius of directing circle which is equal to 75 mm like this. Okay, take any random point O and draw a radius of directing circle which is 75 mm like this. We will give it a name OP. So we have drawn a radius of 75 mm like this. Now from there draw a curved path like this. So from this curved path is of which radius? 75 mm. So what we have done? We have done first we have drawn a radius of 75 mm and then we have put in one arc of 75 mm like this randomly. Okay, so this is the curved path. Somewhere over here the other circle is going to be roll. Okay, so what you have to do? First you have to draw a radius of 75 mm and then put an arc, some like random, something like this. Okay, now what we will do? Now we will draw another circle, but before we will do this, we will call it a curved path, or you can see that this is a directing circle. Okay, so we will only take this much portion. We will not draw the whole circle over, but we will take this much of portion over here, the curved path. So here you can see that this curved path is nothing but it is a directing circle. Okay, now we will draw another circle which is rolling circle. It is having diameter what? 50 mm. So we will draw from point P, we will draw another circle having diameter 50 mm like this. So this is what? Rolling circle, or you can say generating circle. Okay, like this, it is having diameter 50 mm. Now what we gonna do? We will divide this rolling circle into 8 number of equal parts like this, and we will consider the rotation of this rolling circle in a clockwise direction like this. So we will give the numbering in clockwise direction. So 1 2 3 4 5 6 7 and P. So this is how we will give the numbering. Now what we will do? So you can understand over here that OP is showing the radius of directing circle And now you can see that the CP is showing the radius of rolling circle. Okay, so now you can see that. So now here you can see that CP is showing the radius of rolling circle. Okay, now what we have to do? Now we have to draw another line making an angle 120 degree with OP. So like this, making angle theta. Theta what? We have derived the value of theta, which is 120 degree. So draw another line which makes a 120 degree with line OP like this. Okay. So now this much of curved path that we have to consider. So what value of theta? What it shows that for one complete revolution of swirl circle. So here you can say that after 120 degree. So let us say it is the starting position of a smaller circle, right? Over which you can see on your screen. After 120 degree, you can see that this theta value, not rotation of a circle. This theta, after the value of this theta, the one complete revolution of a smaller circle will be completed. So at 120 degree, this smaller circle will complete a one complete revolution. So this much of curved path, this theta of this curved path that we have to consider. Okay, so that's why we have drawn another line which makes an theta angle with OP. Okay, so that's why we have derived a theta. So this much is curved path. So we have a curved path of 120 degree. Okay, now what we will do? Now let us see the point 4 on a circle. So let us see the point 4 on a circle. Now take a distance equal O24 and draw an arc like this up to angle theta like this. Okay, now what we will do? Now theta is 120 degree. So we will divide this 120 degree line. You can see that 120 degree angle. So we will divide this 120 degree angle into 8 number of equal parts. So like this, we will divide this 120 degree angle into 8 equal parts. So 15 degree each like this. Now what we will do? From center, again I am going to repeat, from center. So now take a distance equal to OC. So now take a distance equal to OC and put an arc up to angle theta like this. Yes, okay. So whenever this arc intersect the division, we will mark the position, we will mark the point C1, C2, C3, C4, C5, C6, C7 and C8. Okay, so this is something like this. Now what we will do? Now from point 3, so what we will do? Now take a distance equal to O23. Now take a distance equal to O23 and put an arc up to angle 120 degree. Now again take a distance equal to O22. Now take a distance equal to O22, put an arc up to angle theta like this. Okay. Again take a distance equal to O21 and put an arc up to 120 degree like this. So whenever you draw an arc from point O23, it will automatically pass from the point 5 on a circle. When you draw arc from point 2 on a circle, so taking distance O to 2, it will automatically pass through the point 6. When you draw an arc from point 1, it will automatically pass from point 7. So what you have done? Basically we have taken a distance equal to O to 4, then we have drawn an arc up to angle theta. Now we have taken a distance equal to O to 3, then we have drawn an arc up to angle theta, then we have taken distance O to 2, drawn an arc up to angle theta, then we have taken distance equal to O to 1 and draw an arc up to angle theta. So something like this. Now what we will do? Now first we will darken this C1, C2, C3, C4, C5, C6, C7 and C8. So you will easily understand. So these all are so the C1, C2 center line. Okay, C1, C2, C3, C4, C5, C6, C7, 8 points. I have just darken all these points for our reference. Now first we will darken the point P like this. Now what we will do? After that, for finding the point P1, what we will do? We will use the same concept of cycloid. Take a distance equal to CP, C1 as a center, put an arc on an arc which is passing from point 1. So you can see one arc which is passing from point 1. So put an arc over there. Yes. So then at that point, whenever intersect, it will be a point P1. For point P2, what you will do? Take a distance equal to CP, C2 as a center, put an arc which is passing from what? Point 2. So you can see that one arc which is passing from point 2. So whenever it intersect, it will be a point P2. Same for C3, what you will do? You take a distance equal to CP, C3 as a center, put an arc on a arc which is passing through point 3. So whenever intersect, it will be a point P3. Same for point P4. What you will do? Take a distance equal to CP, C4 as a center, put an arc on an arc which is passing through point 4. Okay, so whenever intersect, it will be a point P4. For C5, same thing. CP as a distance, C5 as a center, put an arc on an arc which is passing from point 5. Whenever intersect, it will be a point P5. Take a distance equal to CP, C6 as a center, put an arc on an arc which is passing from point 6 like this. Whenever intersect, it will be a point P6. For point P7, what you do? Take a distance equal to CP, C7 as a center, put an arc on an arc which is passing from point 7. Whenever intersect, it will be a point P7. And for point P8, what you will do? Take a distance equal to CP, C8 as a center, put an arc on an arc which is passing from point P. Whenever intersect, it will be a point P8. So mark all the point P1, P2, P3, P4, P5, P6, P7 and P8. Name all the point. Okay, up to point P8. And now draw a curve which is passing from all the point, from point to P2, P1, P1 to P2, P2 to P3, P4, P5, P6, P7 and up to P8. So you can see this curve. This curve is nothing but a epicycloid. So I hope you can understand this example. Just quickly revise. Just pause the video if you don't get this. Just quickly revise whole video again. And I think, and I'm very sure that you will understand this concept. So I hope you will like this video. Have a nice day. Bye-bye.